I'm Dr. T and welcome to my office. So today I'd like to talk about phospholipids. Phospholipids are going to look very much like a triglyceride, but one of the fatty acids, one on the ends, isn't there. Instead, that's a phosphate group, or phosphorus surrounded by oxygens. And with that, that's going to change some properties a bit. Now, that's actually what we get for prokaryotes. And prokaryotes like to keep things nice and simple, so that's usually what they go with. You have a phosphate group, which is going to be an anion, so it's going to make the whole molecule an anion. It's very, very polar. It's got two fatty acids. We're going to give these very non-polar, very hydrophobic tails, and you have this amphiphilic molecule. Eukaryotes like to kick things up a notch, and continuing on from the phosphate, they'll stick a couple more carbons, and quite often an amine, quite often a quaternary amine, which will impart more polarity, because that's going to be a cation. So this is going to be incredibly hydrophilic, because you've got the negatively charged phosphate group, you've got the positively charged amine, you might have some alcohols or some other stuff going on here, and as such you've got this wonderfully hydrophilic head to it. And this gets the bonus that this is now what we call a Zwitter ion. Zwitter ions are a molecule that has part of it that's a cation and part of it that's an anion, but the charge of the two cancel each other out. So Zwitter ions are actually not ions. They have like ions in them. They're this really weird kind of thing, and you will see these coming about every now and then. For this reason, eukaryotic cells don't have a charge to them, whereas prokaryotic cells do. And I'll get to here why the cell has the charge from these phospholipids. So they're used in typically one of a couple of different functions. One of the simplest ones to think about is that of a lipoprotein. So a lipoprotein is kind of like a gigantic micelle. And the outside of the micelle is made of phospholipids, the hydrophobic tails going in, and then the phosphate groups, and if it's a eukaryote, which is, if it's going to be a lipoprotein, it's almost certainly a eukaryote, then those are going to be kind of on the outside. And stored inside of the micelle, or I should say inside of the lipoprotein, because it's no longer really a micelle. Stored in the middle is all kinds of hydrophobic stuff that the organism wants to transport. So this is going to be, hey, I need to transport sterols, which are these very hydrophobic molecules, stick them in a lipoprotein and then transport them. And I'll talk more about these guys. If you're thinking, hey, is this like HDL, LDL? Yeah, that's what those are. Now, as the name would suggest, it's not just phospholipids around the outside. There's also lots of proteins. This is, it's not one thing. There's lots of things going on this guy. And yay, okay. Well, we can also do the same idea, and this is going to be done eukaryotes and prokaryotes. Prokaryotes not really doing the lipoproteins, contrary to what I just said. It's going to just be the eukaryotes. But both of them are going to take this basic idea of, okay, I've got a micelle. Well, imagine I stretched out the micelle, and so instead of a ball, it's a pancake. Well, now I've got what I call a lipid bilayer. I have this kind of sheet where I've got the polar heads on the outside and the non-polar tails on the inside. And this actually makes a really good wall, because most molecules can't just pass through it. Because to be able to hang out on the outsides of it, you need to be in an aqueous environment, therefore hydrophilic. And to go through the middle of it, you need to be hydrophobic. So you need to be something that can switch between hydrophilic and hydrophobic. And not many compounds can do that. Hydrogen peroxide, interestingly enough, is one that can do it. But very few other compounds can do this. So this means that this makes a beautiful wall, and this is what's going to comprise the cell membrane. You're going to take that sheet and envelop the cell with it, and that's your wall. And these are very, very useful. Prokaryotes, hey, we got the wall, we're good. Eukaryotes, we're going to use lots of these. Just like your house has interior walls, they're not necessarily there to keep the bad people out of your house, but they're useful to hang up pictures, to divide rooms, just to organize things. And cells do that as well, especially the eukaryotes. They love their membranes. They'll have lots of internal membranes dividing things up. And they make great places to put stuff. You have lots of proteins that are embedded in these membranes, just like you have pictures hung on a wall. You have other proteins that will act like doors and windows. and you've got carbohydrates attached to these, just like you would have, once again, pictures, etc. Walls are very useful, whether you're a cell or you're living in a house or a building, etc. So they're great places to put stuff. And yeah, this gives us this lipid bilayer. Now, as I mentioned earlier, prokaryotes are negatively charged, and that's because they use the simple phospholipids without putting and turning them into Vitter ions. This does allow you to do some rather interesting ways of trying to get rid of them. There's work on pharmaceuticals that will stick to anions and thus allow them to kill the prokaryotes, but ignore the eukaryotes, which is kind of the core of antibiotics. That's still cutting edge research for that particular style, but it's definitely undergoing research. And there's other approaches of trying to get rid of them due to their charge. Now, before I leave you, I should point out there is one other group of molecules that are actually functionally fairly similar to phospholipids. These are called sphingolipids. And in this case, it's basically the same idea, except for the fact that the glycerin and one of the fatty acids aren't there. So you have this long molecule called sphingomycin that basically takes the place of one of the fatty acids and the glycerin, so then a fatty acid attaches to it, what would otherwise appear to be the center fatty acid, and then that's going to have the polar groups and give you the same basic amphiphilic molecule. They're a little bit larger. You see them where you want a thicker membrane. Nerves are going to have these. You're going to see these in lipid rafts and other features in your membrane. But with that said, I'll talk more about sterols, membranes, and whatnot in later videos, and have a wonderful day.